Alright, let's look at the homework 15.2, problem number 3. Alright, so let's evaluate this double integral. Alright, so let's work on the inside. First thing I would do is I'm going to move, since this is with respect to y, so 5x is just a constant. So I will place it outside there. Alright, so let's start with that. So this is going to be an integral from 0 to 3. Alright, so I'm just going to put the 5x outside for now. Then you have an integral from 0 to 1, y square root of x squared plus y squared. And with respect to with respect to y first, then with respect to x. Alright, so here I'm going to use something called the general power rule to make it easier. You can use substitution too, but it saves a little bit of writing. Alright, so when you have some function to the nth power, then multiply by a derivative, then antiderivative is just a g of x, raise it to the n plus 1 over n plus 1 plus c. So let's use that. Right. So if you look at the derivative of this inside this square root here, it's going to be 2y. So derivative of 2y, so I'm going to actually put 2 here. So since I would like to have 2y, then I'm going to divide by 2. Right. So then we have exactly what we wanted. Right. And also remember that square root is equivalent to 1/2 power, so I'm going to view this as x squared plus y squared to the 1/2 power. Right? So using the general power rule, we can evaluate this integral as, right, I'm going to put just copy this part down. Right? So this is going to be, right, so whatever inside, so you have x squared plus y squared, and raise it to the, right, so n plus 1. N in this case is 1/2, so it's going to be 3/2 power. Then you multiply, divide by 3/2 is equivalent to multiply by 2/3. So I'm going to put that. And then this is going from 0 to 1. Then we still have to do the integral with respect to x. Alright, then we can actually do a little bit of cleaning up. So you have 2 on top, and there's 2 on the bottom. And I can probably move this guy out here. Alright, so what you get is going to be integral from 0 to 3. And you have a 5/3. Alright. And then x, right, if you plug in 1 here, so you have x squared plus 1 3/2 power minus plug in 0, so you have x squared, raise it to the 3/2 power, so it's going to be x cubed, right, and dx, right. And I'm going to distribute this x to both of these guys. Actually, I'm going to actually distribute the 5/3 too. Alright. Actually, no. Take that back. Let's see. I'm going to actually, 5/3 is just going to be a number, and I'm going to place it out here. Alright, so what you get is going to be, right, so 5/3 is just outside. Then we just have to integrate from 0 to 3, right? So apply that. So you have, let's see, you have x times x squared plus 1 3/2 power, and a minus x to the 4th power, right? Right, dx. Right, then we want to find the antiderivative. So here you have 5/3. Leave this guy alone. All right, then here what I need to do is a derivative of x squared plus 1 is 2x. So I would like to have 2 here. Then I have to have a 1/2 in front. So you're going to have a 1/2. Oops, here. It's going to be 1/2 is there. But the antiderivative of this is going to be x squared plus 1. Add 1 to the power, so it's going to be 5/2. Then divide by 5/2 is equivalent to multiply by 2/5. Right there. And a minus, right? Antiderivative of x to the 4th is x to the 5th power over 5. Right? Then you're going from 0 to 3. Right? Then what we can do is we can do a little bit of cleaning up. So you have 2 and 2 cancel out. Then I'm going to go ahead and I think I'm going to go ahead and distribute 5/3 to the first term and also the second term. Then you end up getting, right, so 5 and 5 cancel out. So you have a 1/3. Right, x squared plus 1 to the 5/2 power minus also 1/3 because 5 cancel out, and we have x to the 5th power. Right, then going from 0 to 3. Right, then we can just plug this in. So I'm going to go up here. Alright, so plug in 3, so you have 9 plus 1/3. I'm going to actually pull out the 1/3, right? Then here, if you plug in 3, so 3 squared would be 9 plus 1. So you have a 10 to the 5/2 power, right? And a minus, right? Plug in 3 here, 3 to the 5th, but there's a 3 there, cancel out. So it's going to be, let's see, 3 to the 4th power. So 9 to 9, so 81. So 81 here. Then I have to actually put, let's see, 1/3 here instead. Okay, instead of putting it out. So we have that. All right. Then minus, right, plug in 0. So it's 0 is going to be 1/3. And plug in 0 is 0. So this is going to be, let's see, is there any way to clean this up a little bit? I guess we can pull out the 1/3 outside, right? And then you would have a 10 to the 5/2 power, right? So if you pull 1/3 here, so it's going to be negative. So 81 becomes, you have to multiply by 3. 1 times 3 is 3, and 3 times 8 is 24. Right, then minus 1. Right, so this is going to be 1/3, and I can probably use the parentheses here. 10 to the 5/2 power minus 244. Right, so we got that. All right, let's plug it in. All right, so we have, let's see, I forgot what it was. 1/3, yep. So 1/3, parenthesis, 10 to the 5/2. Right, I don't like the parentheses. I'm going to just erase that parentheses there. And minus, and 244, was it? 244, right? So plug in 244, right? And the parentheses. All right, so let's type it in. Oops. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.